All right, we're starting the second page, and we have a system of linear equations in 3 variables, which oftentimes freaks people out. The only problem with these problems is that they can be pretty tedious, so you got to be super duper careful with all the signs and the multiplying, everything, to make sure that you don't mess up one thing, otherwise the whole answer will be off. So first I'm going to label these as equation 1, 2, and 3. And I have to work with all 3 equations. I can do 1 and 2, and then 2 and 3, or 1 and 3, and then 2 and 3. It doesn't matter, just as long as all 3 are used one time, and there will be 2 steps, so one of them will have to be used at least twice. So what I'm going to do is I see that the equation number 3 has a negative 2. Equation 1 has a positive 2, and equation 2 has a positive 2. That's awesome. I mean, I can look at the other columns and see 3, 4, 3. That means I'm going to have to multiply multiple equations. 3, 2, 5. Again, multiple equations. I like this, okay? I like opposites, okay? So if I added equation 1 and equation 3, I know that 2x plus negative 2x would be 0. That would automatically eliminate our x's. So that's what I'm going to do. Equation 1 and 3. 2x plus 3y minus 3z. Be very careful that you copy correctly. 1 and 3, negative 2x minus 3y plus 5z equals 13. Add. Oh, that also gives me 0. So I get 2z equals 6. And so z is equal to 3. Now normally we'd have a yz equation, but we actually have a value for z. But we still have to do our second step, because having a value for z, if you plug it into equation 1, 2, or 3, you'll still be left with x and y that are unknown, so you won't be able to finish the problem. So now we're going to take equation 2 and 3 and add them over here. All right, so we're taking equation 2, and we're adding it to equation 3 to again eliminate our x's. Negative 7y plus 3z equals negative 5. Now we have equation 4. Well, this is technically equation 4, but it's just a value. Now we have equation 4 and equation 5. But since we just have a value, an actual value for z, we're going to plug that into this z and get y, and then plug the z and y into one of our top 3 equations. So, negative 7y plus 3 times 3, which we know our z is, equals negative 5. Negative 7y plus 9 equals negative 5. Subtract 9. Negative 7y is equal to negative 14. So y is equal to positive 2. Awesome. We found another one. And now we have y and z. We're going to plug it into one of our original equations. I'll just choose equation 1. It doesn't matter which one, but equation 1 has less negatives in it. So 2x plus 3 times y minus 3 times z equals negative 7. Y is 2, z is 3. Solve for x. 2x plus 6 minus 9 equals negative 7. 2x minus 3 equals negative 7. Add 3, I'm running out of room. So I have 2x is equal to negative 4. X equals negative 2. Your answer must be written as a coordinate point, x, y, z, so negative 2, then 2, then 3 is our solution. Sorry, I realized I did not show you those last few steps. Okay, so 2x equals negative 4, then you divide. Your answer is written as an x, y, z point.